let us learn the truth tables. The truth tables are very easy to learn. The truth tables will tell us exactly what the function of each gate is going to be. So the first gate that we need to focus on is the NOT gate. It looks like this. We have an input, we have an output. Now we have to also remember one small expression, okay, for the output. The output expression for the NOT gate is the inverse of the input. Very simple. So what does this mean? If I need to draw a truth table of the NOT gate, I will have to show the input, the output, which is A and Y. Now the input we know can either be 0 or it can be a 1 because we are only using these two digits as our digital signals. So let us see, if I use a 0, what's going to happen? We know that the algebraic expression, the Boolean expression, okay, is actually the inverse of 0. So it is going to be 1, and if I give 1, it is going to be 0. We go to the next gate. It is called the OR gate. OR gate looks like this. All of us know that. A, B, and we have the output. You can also show outputs like this, okay, and inputs like this. So that's fine. Now the expression for the Boolean expression for your OR gate is nothing but A plus B. Okay. So what does that mean? Let us draw a table for this. A trick to, solve problems based on logic gates is to remember your Boolean expressions, because if you know this, you don't have to think a lot, okay, you just have to apply the numbers and you'll get your answer. We know that the input here, if you look at how the OR gate is constructed, it has two inputs. So the input is actually going to be divided into two parts, and it's going to be named A and B, whereas the output has only one, which is the Y. Now again, digital signals can be zeros and ones. So let me do a combination. So this is how you're going to remember. The first time, okay, you're going to take both as zeros. That means both the inputs that enter in this gate is going to have 0 input. So 0 will enter here, 0 will enter here. And what is the expression for the output? It is A plus B, and 0 plus 0 would therefore be how much? It would be a 0. Okay, and that is how your answer will be 0. Now in the second part, okay, I'm going to take a smaller eraser. In the second part, what we are going to do, we are going to clean this off. I'm going to take A to be 0, but I will change this to 1. I will change the input of B as 1. So let us see what will happen. So 0 will go in like this and 1 is going to enter from here. The answer should be 0 plus 1, which is equal to 1. And yes, our output is going to be 1. Okay, go to the next one. So next combination we are going to do, cleaning this off. Next combination we are going to do is 1 as our input at A and 0 as our input at B. We are going to change it. So here we are going to get 1 and here we are going to get 0. Answer is going to be 1. And the final combination would then be 1 and 1. Okay, so my final combination is 1 and 1. Now if I add 1 and 1, I know the answer is 2, but in digital signals, in this setup, We are not going to add it to 2, but it's actually going to be 1. Okay, that's it. This is your truth table for the OR gate. We move on to the next one, which is the AND gate. The AND gate looks like a D. Looking at the AND, the A and D part of it, you should remember this. A, D. Okay, the Boolean algebra for this is, when I say AND, it is a option. So it's like this and this. Okay, so A dot B, it's a multiplication. This and this. Okay, so it's combining two inputs. So my output would be A into B. So let us see how that works. This truth table looks a little crooked, so I am going to redraw this. The AND gate, okay, actually is a very easy gate to remember, because it works on the multiplication principle. Again, we have the input. We know, again, AND gate has two inputs. So I will have to draw two lines here, A and B, and my output will just be a Y. Combination remains the same. The first one is going to be 0, 0, 0, 1, 1, 0, 1, 1. Okay, let us start. The first one, if I put 0, 0, answer is going to be 0 dot 0, answer will be, everybody think, it's going to be 0. Okay, next, if I have 0 and 1, I'm going to give you a moment to think. This is 0, this is 1. Answer will be, yes, it's going to be 0. And if I change the order, if I put A as 1 and B as 0, it's still going to give me a, yes, it's going to give me a 0. And finally, we have the last combination, which is a combination of 1 and 1. So 1 and 1 would be 1. Yes, there you go. This is the AND gate truth table. Okay, very simple to remember and write. And now we come to the final two, which is the NOR gate and the NAND gate we will do after this. So the NOR gate looks like this, with a NOT in front. A, B inputs, the output is going to be Y. But we already know that the AND gate is a combination of OR gate and NOT gate. It is a combination of OR plus NOT. So what is the Boolean expression for OR gate? Okay, so if you remember, Boolean expression for OR gate is a plus sign. So we are going to write that A plus B. And the NOT part of it, looking at the Boolean expression for the NOT gate, it is the inverse of it. That's it. This is the Boolean expression for NOT gate. Very simple to write the truth table of this gate. You will have to draw again two inputs. Okay, you mention input. You have to write A and B, and your output, which is going to be a Y. Okay, so input again 0, 0, 0, 1, 1, 0, 1, 1. And the output, now how is the output going to work? We know that if I put 0 and 0 in A and B, output is going to actually be 0 plus 0, which is a 0. But this is a NOR gate, which means it's an inverse. So you will get 1. Next one, 0 plus 1 will be 1, but the inverse of 1 will be, yes, it's going to be 0. The next one, I have 1 here and 0 here. Answer will be 1, but it is also an inverse, which is going to give me a 0. And the last one, where both are 1s. Okay, 1 and 1 is 1, but it's an inverse. So the answer is going to be 0. It's a very, very simple truth table for the NOT gate.